Was I muted the whole time? Fine.
Yeah.
That's good. Okay, that's super awkward. I was talking the whole time and I was wondering why nobody was saying anything. All right, so good noon, everyone. How are you all doing? So we'll ignore that. We'll pretend that it never happened. We'll pretend that it was intentional. Anyway, so in the Zoom chat, I want you to do. So there is a 10 so there's a 10 kilogram shake weight. So I don't know if you were alive back when shake weights were a thing. Shake weight's probably a thing like 5, maybe even 10 years ago. That may be before your time. Shake weight's hilarious, by the way. If you don't know what they are, you should definitely look them up. But there's a 10 kilogram shake weight. It's lifted 5 meters off the ground. I want you to find the change in kinetic energy. I want you to find the change in potential energy, and I want you to find the total work done. Whenever you're ready, put your answers in the Zoom chat, and let's see what we can get. To figure out the change in kinetic energy, you want to think about how fast is it moving initially, how fast is it moving at the end. For the change in potential energy, you want to think about how much potential energy, how high am I in the beginning, how high am I at the end. Ooh, how fun. Who doesn't love having altitude and being high? And then find the total work done at the end. Whenever you're ready, put those answers in the Zoom chat. Let's see if we can get some answers. Anyone have any ideas of what our change in kinetic energy is to start off with? Is it 100 joules, 1,000 joules, 1,000,000 joules, 15 joules, 67.24 joules, 15 joules, 16 joules? Any ideas? We got one answer so far. We got Jose with an answer. I do want to see if we can get some more answers though. We got some more ideas. Anyone think there's 10,000 joules? Anyone think there's 10 joules? Okay, here's a better question. How much kinetic energy does it have in the beginning? Does the shake weight have in the beginning before I start lifting it? Okay. How much kinetic energy do I have after I lift it off the ground and I stop lifting it? So I lifted the shake weight to the top, 5 meters above the ground, it's in the air, and then I hold it there. Oh, okay, now we got some answers. Okay, we're popping. Okay, so then what's our change in kinetic energy then? Nice. All right, so let me see if I can sum up what we talked about in the chat, right? So our change in kinetic energy, this is the difference between our final kinetic energy minus our initial kinetic energy. So, right, initially, the shake weight is not moving. And after I lift it to the top, it's still not moving. So the initial kinetic energy is 0, the final kinetic energy is 0, so the change in kinetic energy is just 0. This is very important, and I think the best way of thinking about this is if an object, oh, I should switch to the board now. Okay, so, right, if an object is not speeding up or slowing down, right, there's no change in kinetic energy. Right, because it's not getting faster or slower. So the kinetic energy isn't changing. So this is like, we don't even need to really do this calculations because we know that it's not speeding up, it's not slowing down. All we know is that it's changing its height. All right, bam, bam. That's not too bad. Now let's figure out our change in potential energy. So to this, right, we're going to look at our initial potential energy and we'll look at our final potential energy. So our change in potential energy is our initial potential, final potential energy minus our initial potential energy. So here's what we're going to do. We are going to recognize that, okay, our initial potential energy, well, we're lifting it off the ground. So that means the height here is 0. And if the height here is 0, the potential energy is also 0. All right, how do I do this? Well, I'm like, okay, the change in potential energy is my final potential energy minus my initial potential energy. My height is 0, so my initial potential energy is just 0. Fun. Okay, and then, okay, let's look at our final potential energy. Right, so to figure this out, you know that the final potential energy is our mass times gravity times height. Now I'm just going to put a little f down here to signify this is our final height. This does not mean h times f. It just means the final height. This is very important. Okay, so what is my mass? The Higgs equates mass is 10. What is g? G is always 10. And then what is our height? Our height is 5. What's 10 times 5 times 10 is, this is 500 joules. Okay, so that means our change of potential energy is also just 500 joules. Okay, so now let's figure out our work. Our work is our change in our total energy, which is the same thing as the change in our kinetic energy plus the change in our potential energy. Okay, we know that our change in kinetic energy was just 0 because it was neither speeding up nor slowing down. And we know that our change in potential energy is 5 hundos, 5 stacks. 5 stacks, so that means our work here, our total work here is 500 joules. Okay. That wasn't too bad, I think, hopefully. I think it's kind of scary initially because you're like, I don't know how to find work. I don't know how to find this change in kinetic energy. And I think it helps if we just break it down initially. We just want to think about, is it speeding up or is it slowing down? If it's not speeding up or slowing down, right, our change in kinetic energy is 0. We look at our change in potential energy. If it's going up or down, then there is a change in potential energy. If it is not going up or down, if the height is the same, there's no change in potential energy. So this would technically be 0 as well. But in this scenario, because we are lifting it up, there is a change in potential energy. So all we did is we compared our initial potential energy to our final potential energy. Our initial potential energy, because we start from the ground, our height is 0. So our initial potential energy is also 0. For our final potential energy, we just use our mass times our gravity times our final height, which means that our mass is 10, gravity is 10, height is 5. 10 times 10 times 5 is 500. And so our change in potential energy is 500 joules. Okay, does anyone have any questions for me so far? Okay, so here's what we're going to do today. So I first want to just talk about grades because I have been very busy grading stuff the last day or two. So at this point, I pretty much have everyone's stuff graded. Because quarter grades are due very, very soon, and by mean very soon, I mean the quarter ends tomorrow technically, and we can submit grades within the next few days. So if you have anything that you want to submit, I would highly advise you submit it now. I've already started putting in zeros for people who haven't submitted part 3 or part 4. If you submit something, right, I will just erase the 0 and I will actually grade it. But if you never submit it, then you will get a 0 for that, which is unfortunate. I also have put in preliminary final grades as well. I mean, those will be subject to change depending on whether or not you submit stuff and continue to revise stuff. You can revise stuff even after the quarter. That's totally okay. Part 3 and part 4 are graded. Part 3 and part 4 are graded. Part 1 and part 2 are not graded. If I gave you a 0 on a section, that's a graded section. So that means you should do it. Okay. So I would highly recommend you submit it. Yeah, and so if zeros will definitely hurt your grade a little bit. So I recommend you submit it. Again, these grades are preliminary quarter grades. I will update them as you revise stuff as well. You can see your total grade in Canvas. I've unhidden it. I've only given you a letter grade. I want you to ignore the percentages. For a lot of people, they might see something like 93% when they actually mastered everything. That's okay. It does not mean that you are missing points. Canvas just does a weird thing where an A means a 93%. And it's kind of hard to explain, but just look at your masteries and see what you've mastered. That's the best way to look at your grade. Okay, so if you have any questions about grading, you can always just let me know. But for now, I'm just going to shift us over to what we're going to be doing today. So what we're doing today is we're going to keep working, on work. So last week, I believe I shared the next assignment. I'm going to put the link in the chat again, just so you can see it. I know you probably already made your copies and started working on it. I'm sharing it right now because I've made some changes to it to hopefully make it a little easier and give you a little bit better of a setup. So I would recommend at least copy and pasting, at least if you've already made a copy, I recommend just copy and pasting this over, or I just recommend starting from scratch and just opening the new one. Yeah, I would recommend doing that. Just the old one. The old one's gonna be a little bit harder and a little bit more harder to understand, I think. So this should be a little bit easier and hopefully help you along the process. So we're just gonna keep working on this throughout the rest of the class. If you finish this early, I would recommend starting on the mastery assignment, which is on campus as well. But I don't know if people will get there today. So that's what we're going to do today. And if you don't have any other questions, I'm just going to let you get started, and then I will see where everyone is at. If you don't do part 6, you will not receive a 0. You only receive a 0 for part 5. No, not part 5. You only receive a 0 for part 3 and part 4. Part 5 and part 6 are optional, but if you want to receive an A, then you need to do those parts. So you're not penalized for not doing them, but you are instead rewarded for doing them. So that's how I would think of it. Yeah, so you don't get a 0 for it. You just get a blank. If that answers your question. As far as when is part 6 due, I mean, you can submit it whenever you finish. If you want it to go in your quarter grade, you should submit it within the next day or two. If you want to take more time to work on it, you can submit it after the quarter, and I will still grade it, and there won't be a penalty for that. So it really just comes down to, do you want it to go in your quarter grade or not? So I'm gonna do another work problem, so you can see, how else you might try it. If you already feel comfortable on it, you can just mute me for now and then just keep working. If you want to see how to do another kind of work problem, I'm just gonna do another one on the board, so you can at least get a visual and see, the different kinds of problems and how you might approach them. So what I'm going to do for this problem is I'm going to give us a little bit of a different style of problem. Okay, so what I'm first going to do is I'm going to first say that, okay, we have a car. We have a car here. I don't even know. Okay, that's a car. Okay, so the car, let's say this car has a mass of 100 kilograms and it's moving at 20 meters per second. So I want to figure out how much work it takes to stop the car. So if you're watching this, if you want to sort of see how I do it, I would recommend taking notes and at least sort of looking at how I do it. I would highly recommend it. So I think the first thing we want to do here is we want to identify what we already know. So what I first want to do is identify, okay, I know my mass. My mass is 100 kilograms. I know my initial velocity. VI means initial velocity, which is 20 meters per second. So, okay, so we know these for sure. There's a few other things that we know as well that you might have to do a little bit more thinking to realize, but we also know our final velocity. The thing is, the final velocity was not given here, right? I don't say how fast the car is moving at the end, but there's a key word here, stop, right? What does it mean to stop a car? Well, when a car is stopped, right, it stops moving. It has no more velocity. So if we want to figure out how fast the car is moving when it stops, well, we just look up what the word stop means. So we know the car is moving at initially 20 meters per second, and we know at the very end, we want our car to be stopped. So if our car is stopped at the end, it has a velocity of 0 at the very end. Okay, so if this is kind of important, right? This is very important. I didn't tell you that the final velocity was 0, but I told you that we wanted to stop the car. So you have to make that deduction yourself and say, okay, when I want to stop the car, I need to realize that, okay, my final velocity is 0 because it stops moving. And there's gonna be a lot of problems like this where I'll tell you some information and you have to extrapolate the rest. Okay, so that's our final velocity. Here's another very important one to extrapolate right here. You also can extrapolate the change in potential energy. Very important. This is probably the hardest one to extrapolate. Hardest one. By far. Hardest one to find out. Hardest one to determine. Because you're like, okay, the change in potential energy, that's like how high up am I initially, how high at the end, it's like, oh, so much potential energy. It can be kind of overwhelming. The simplest way to think about this is, am I moving up or down? If I am moving up or down, this is not 0. If I'm not, if my position is stationary, as in terms of my height is the same, even if I'm moving faster or slower, my change in potential energy is 0. In this problem, I have a car that's moving forward, but its height is not changing. If my height is not changing, my potential energy is not changing. This is very important, and I want you to remember this. Remember this. I don't want you to forget and start thinking, okay, I don't know how to find the potential energy of something that is moving, that is on the ground. Because remember that if the height is not changing, change in potential energy is 0. Okay, so now let's figure out how to do this. So we first want to identify the unknowns. So this is our given. Our next one is unknown. We want to figure out what we want to find. So in this problem, we want to figure out the work. Now, in order to figure out the work, we also need to figure out our change in kinetic energy. So we do need to figure out our change in kinetic energy to figure out our work. And let's figure out our equations. So our equations that we're going to work with is that our work is equal to our change in kinetic energy plus our change in potential energy. And then there's one other equation that we want to use because we want to also figure out our change in kinetic energy. So what does it mean to have a change in kinetic energy? It means that there's a difference between the final kinetic energy and the initial kinetic energy. This is also very important, understanding how to figure out our change in kinetic energy. Okay, so let's substitute. So we can't substitute anything yet for the work equation, but we can for the kinetic energy equation. So what I'm going to say is that, okay, our change in kinetic energy, which we don't know, is equal to my final kinetic energy, which is 1/2 times my mass times my final velocity. Right, because this is my final kinetic energy. So I need my final velocity. This needs to be squared, don't forget the squared, minus the initial kinetic energy. The initial kinetic energy is 1/2 times m times vi squared, with vi being initial velocity. Okay, so there's a couple of things we can immediately do. Remember that our final velocity was 0 because we want the car to stop. So we know that this has to be 0. So that means our change in kinetic energy is equal to our negative 1/2 times mass times velocity initial squared. This is equal to negative 1/2 times 100 times 20 squared, which I believe is 400 times 100 is 20,000. But there's one other thing we need to remember is that this is a negative 20,000 because we are slowing down the car. So there's a negative work. Okay, so this is how we substitute for this step. Then we're going to substitute this back into here. Remember that our change in potential energy is 0. So that means our work is just equal to our change in kinetic energy, which is just 20,000 joules. That's how you would do a sort of change in kinetic energy kind of problem. Hopefully that helps those of you who are a little confused. Okay, do you think that helps?
I have a question, Mr. Hu.
Go ahead.
But like if the velocity is that given to
Miguel, you're fine for me. I'm echoing?
Yeah.
Oh, it's because my
So I think the teacher might have gotten disconnected. It's already 1:04, so I think you guys are good to leave.
All right, thank you.
Uh-huh. Okay.
Bye.
Bye.
Thank you.
So it's 1:09. I think most people have already left, which is fine. I just for homework, just keep working on parts 3, 4, 5, and 6. You don't need to keep working on the work proficiency one. We'll keep working on that next week. Tracy, if you run into any questions with the last problem, Tracy, you can let me know if you feel like you've run into a wall, and I'll see if I can give you some more help. Otherwise, you're free to go, and you can come to my office hours whenever, today or tomorrow. So farewell. Bye-bye.
All right, bye, Mr. Hu. Thank you.
Yeah.
Mr. Hu, I have a question. Another one.
No. I'm sorry. I think I'm really funny. I'm sorry. Go ahead.
Okay, what's it called?
Okay.
I turn in all my work tonight. Can you, or like before Friday, right? Or yeah.
Yeah.
Will it count towards my progress report?
Yes.
Okay. Thank you.
Yes. I'll turn it in ASAP. Because I probably won't grade anything past like 6 or 7 p.m. So I might get the grade tomorrow morning, but I'm just being realistic here. I don't like doing work when I'm at home.
Okay.
Okay.
All right. Bye.
Okay. Farewell.
Okay, for the last question,
Mhm.
do I use my mask? I use my mask for my roller coaster, right?
Yes, you would.
Okay. But okay. I'm so stuck.
Okay, let's see. Okay, so I will help you, but I will try to mostly make you figure it out. I'll just
Okay.
I'll just see if we can clarify some things. Okay, so let's see if we can clarify some things first. Okay, so first off, we are doing 10,000 joules of work.
Mm-hmm.
Yeah, we already talked about this. We're doing 10,000 joules of work, and we know this is my change in energy, and this is my change in kinetic energy plus my change in potential energy.
Mm-hmm.
Right. So when I do this work, I am changing my kinetic energy and I am changing my potential energy. So if I'm trying to maximize my height, where do I want to put this energy towards?
I say potential energy.
You say potential energy. Okay. So do you want to put all of it in potential energy? Do you want to split it? Do you want to do 50-50, 25-75? How do you want to split this energy? Or do you want to split it?
It's because it says your roller coaster is on the ground. Right?
It's starting from the ground.
Oh, okay.
And
I
you
don't
want to
know.
lift it to as high as you can.
So I have to decide how to split it.
So you want to maximize your height. So when you do this much work, right, you want to figure out where do I want to put this energy. And so I mean, you can decide where you want to split it, but there is a way to figure out what's the best way of getting the most height of your roller coaster.
Mm-hmm.
So do you want to give your roller coaster a lot of kinetic energy? Do you want to give it a lot of potential energy?
I mean, we can try a lot of potential energy.
So we want to do a lot of potential energy. Okay. So do you want to give it like 75%? Do you want to give it like 90%? 50-50? 100-0? Which one do you think? Which one do you want to try to do?
75-25.
175. Okay. So let's so which means that you are going to spend some of this energy into making it go faster.
Mm-hmm.
Okay. So that means you spent 7,500 into increasing your potential energy. Okay, now your roller coaster has 7,500 joules of potential energy, which means it's somewhat high. Okay, but that means you also have 2,500 in kinetic energy. So this looks pretty high right now to me, but we want to make it go as high as possible. So do we need to give your roller coaster any kinetic energy? Do we have to?
I don't think so.
Is there a rule? Did I
No.
give you a rule that we have to give a roller coaster kinetic energy?
No.
No, I didn't give you a rule. I didn't tell you because if you think about it, right, there's a lot of times where all what I've done is I've lifted something up and I gave it potential energy, but I never actually gave it kinetic energy. So do we even have to give the roller coaster any kinetic energy?
No.
Okay, so we don't have to give them any kinetic energy. So how much potential energy can we give it at most?
The 10,000.
10,000. So this is the most potential energy we can give it. So from this, you can figure out your height now. Maximum height.
Oh. So it would be okay. So I did my mass to 5,000 and then my gravity is 10. I don't know my height. So it would be 5,000 times 10, which is 1,000 times 10 is 50,000. Now divide that by 10,000. I got a decimal.
Yeah, it should be like 0.2.
Yeah, I got 0.2.
Yeah, it's gonna be pretty small. Yeah. It's the process that matters. It's the process that matters. I can't give everyone like realistic numbers every time. So 10, yeah, you're right. It's 0.2. So since you know how to figure out your maximum height, I cannot help you anymore with figuring out your maximum velocity, since I think you already know how to do it.
I would do the opposite, right?
I cannot help you anymore. Since you already know how to do the potential, I won't help you anymore. I feel like you're too confident now.
Oh, okay. I know what to do.
Okay. So you didn't even need me to tell you what to do. You already know what to do.
Okay, thank you.
Okay, perfect. Perfect.